Welcome to our next lesson where we're going to determine trig ratios of angles in radians. So in the last video we just introduced what radians are, and they are a different way of expressing angles, just like degrees. So now we're going to apply exactly what we've learned before for exact values in degrees, but now it's going to be in radians. So hopefully you took a look at your unit circle in radians and also your special triangles in radians, because you do need to know them in order to do these type of questions. So if you don't have them memorized yet, I would suggest you draw this again and again and again until it sticks in your brain. So let's go ahead and try similar questions of what we've been doing before in degrees, but now they're just going to be in radians. So we want to find the exact value of cos of 4 pi over 3. If you look to see where 4 pi over 3 is on the unit circle, it's located right over here, which is the same thing as 240 degrees. So you are kind of finding cos of 240 degrees. And if you find that answer is going to be the same as cos 4 pi over 3. Some students like to keep converting between radians to degrees for them to solve because it's easier for them, but I really suggest you get used to using radians because you will be seeing radians a lot in the future, especially if you take calculus. So just keep everything in radians, and we're just going to get comfortable in calculating our exact values in radians. So the exact value of cos of 4 pi over 3. The first thing we're going to do is find the reference angle, and it's pretty easy to do because all you have to do is just remove the numerator and then the number in the numerator, that's 4, and that is going to be your reference angle. So our reference angle is pi over 3. This is going to be the same case for any other angle. So let's just say you have 2 pi over 3, your reference angle is still going to be pi over 3. If you have 7 pi over 3, your reference angle is still going to be pi over 3. Next thing we're going to do is determine what quadrant this thing is in. And when we looked at it in the unit circle above, it was in quadrant 3. If you didn't know that, that just means you don't have this 4 pi over 3 memorized. So make sure that you do have it memorized so that you know what quadrant it belongs in. And I kind of gave you a hint in the other video that you can memorize your angles in each quadrant by patterns. So your first quadrant would be pi over 3. Your second quadrant is going to be 3 minus 1, which is 2 pi over 3. And your third quadrant is going to be 1 more than your denominator, so that's 4 pi over 3. And then for quadrant 4, you would do 3 times 2 minus 1, which is 5 pi over 3. So that's one way of thinking about all of your angles if you just want to memorize quadrant 1 and then remember the patterns for the quadrants after that. Anywho, we are dealing with quadrant 3 here, and that means that our exact value is going to be negative in the end because that's cosine is negative in quadrant 3. I'm just going to write this as a note. That our exact value is going to be negative just because cos is negative in quadrant 3. Next thing we're going to do is find the exact value part. And we're going to use our special triangles for that. So just looking back up here, we're going to use our pi over 3 triangle, which is this one. And we are trying to find cos of pi over 3, which would have the same exact value as cos 4 pi over 3, but it would be negative. So for cosine, we have adjacent over hypotenuse. So your adjacent is 1, your hypotenuse is 2. So that your exact value then is 1 over 2. And don't forget your negative, because we just stated in the second step that cos 4 pi over 3 is negative because cos is negative in quadrant 3. And that would be our final answer. For our next question, we're going to determine the exact value of tan negative 7 pi over 3. So our very first step when doing this one, because negative 7 pi over 3 is not a part of our regular unit circle from 0 to 2 pi, so I'm going to find another angle that's very similar. So So we're going to find the coterminal angle then. And we usually do this by adding or subtracting 360 degrees. Because we're in radians, 2 pi is equivalent to 360. So I'm going to add or subtract 2 pi to find a coterminal angle. In this case, because our angle is negative, I'm going to add 2 pi. Because if I subtract 2 pi, we're just going to get a larger negative angle. So in order to add this, I'm not going to be using calculators, so I will have to remember how to add fractions. We need a common denominator. So I'm going to multiply 3 top and bottom to 2 pi, which will give us 6 pi over 3. Adding those together, we get negative pi over 3. So that is a coterminal angle of negative 7 pi over 3. The second thing we're going to do is find what quadrant our angle's in. Because our angle is negative, usually we would go counterclockwise to figure out our angles in the positive direction. But if it's negative, we go clockwise. So this would be 0 degrees, negative 90 degrees, negative 180 degrees, and that's what it would look like if we're going the negative side of things. But because we're in radians, I'm just going to write this in radians as well. So this would be negative pi over 2, negative pi, negative 3 pi over 2 equivalently, and then negative 2 pi. So that means negative pi over 3 is going to belong in quadrant 4 because it would fit in between 0 and negative pi over 2. So negative pi over 3 fits in between 0 and negative pi over 2. That's why it's in quadrant 3. This means tangent is going to be negative there because it's in quadrant 4. So we're going to keep that in mind for the final answer. Now we're going to find the exact value. Our reference angle is pi over 3. Again, you just remove this negative 7 here, and that would just give you your reference angle. So again, we can refer back to our special triangles. If we're looking at tangent of pi over 3, that is opposite over adjacent, so that is root 3. So root 3 is part of our exact value. And then from step number 2, we figured out that tan negative 7 pi over 3 is going to be negative because this angle of negative 7 pi over 3 is in quadrant 4 and tan is negative there. So this is our final answer, negative root 3. Moving on to C, determine the value of cosecant 2 pi over 7 to the nearest hundredth. Just because it says the nearest hundredth, I can tell right away that we're going to use a calculator. And this is also not an exact value type of question because 2 pi over 7 doesn't look familiar for us in terms of the unit circle. And when you are using your calculator, you're going to make sure now that your calculator is in radian mode. So not degree mode anymore, but in radian mode. And if you don't change that, you're definitely going to get really weird numbers or numbers that just don't make sense. So make sure, again, if you're going to use your calculator and your angles in radians, make sure your calculator's in radian mode. There should be an RAD or some sort of mode button in your calculator that you can select for that. Okay, so to find this, because we are using calculator, this is pretty easy. The first thing we're going to do is figure out what quadrant it's in, because this will help us determine if this exact value you're going to get is going to be positive or negative. So for 2 pi over 7, we have a calculator. So we can literally just type in 2 times pi divided by 7 to figure out what quadrant it would be. And you look at the decimal number. So remember, this is pi over 2. So you can figure out what that number is. You know this is pi, which is 3.14. So if you put in 2 pi over 7, you will get some sort of decimal number that's going to fit in between pi over 2 and pi, which is in quadrant 2. So this is our question. It's cosecant, but we don't really like to deal with our reciprocal trig functions. So I'm going to change this into sine, and I can do that by taking the reciprocal. Remember, it's not the reciprocal of the angle, it's the reciprocal of the exact value. So all of this can be changed as 1 over sine of 2 pi over 7. So I'm going to write a note down here so you don't forget. Reciprocal trig, not reciprocal angle. So it's a reciprocal trig ratio, not a reciprocal angle. So you're not going to say 7 over 2 pi. Do not do that. So I'm just going to type this into your calculator, 1 divided by sine of 2 pi over 7, and you're going to get 1.279. And that is your final answer. Because our angle's in quadrant 2, cosecant is also positive in quadrant 2, so I'm just going to leave it as positive. So there are 2 questions there. You can try them on your own right now, and then when you're ready, press play and I'll give you the solution. For the first one, we're looking for sine of 11 pi over 6. That means pi over 6 is our reference angle. We would just get rid of this 11 to help us determine what our reference angle is. And then we're going to use our triangle to help us determine what sine pi over 6 is. So looking back at our special triangle, sine of pi over 6 is opposite over hypotenuse, which is a half. Okay, and then we also need to figure out what quadrant it's in so we can determine if it's positive or negative. 11 pi over 6 is in quadrant 4. You just refer back to your unit circle to figure out what quadrant it's in. And sine is negative there because it's in quadrant 4. So it's going to be negative a half for that answer. Your last question is determine the exact value of secant, negative 13 pi over 6. If you look at our first step, it's exactly the same type of question as B. We have a reference angle pi over 6. You can tell that right away. You also probably want to find the coterminal angle. And we're going to add 2 pi to figure that out. So negative 13 pi over 6 plus 2 pi. This would give us negative pi over 6 after you simplify it. And that means our angle belongs in quadrant 4. That's where negative pi over 6 would be. And secant is positive there. So that means our exact value will be positive. Then we're going to find the exact value now. But we can use secant. That's fine as long as we use our triangle. So we're going to refer back to our triangle for pi over 6. So here's pi over 6. For secant, it is hypotenuse over adjacent. So that's 2 over root 3. And then the last thing we would need to do is figure out if this is positive or negative. I already stated it's going to be positive because secant is positive in quadrant 4, and we already found that negative 13 pi over 6 is in quadrant 4. So that is your final answer.